starting on number 8 for the graph above. Let me erase some of this, just move it out of the way. Actually, let me leave it for now. For the graph above, circle the correct answer for each of the following on the interval pi to theta 3 pi over 2. So this is talking about this portion of the graph from pi to 3 pi over 2. This portion of the graph. It wants to circle something about each. So this first bullet point has 1, 2, 3 things to answer. So the function itself is going down, so it is decreasing. The function itself is above, like from here to here, it is positive because my y values are all positive. And then this portion of the graph here is concave down like a frown. Okay. And remembering the two different definitions for concave up and concave down help always. So remember, for concave up, you always have an increasing rate of change, and for concave down, you always have a decreasing rate of change. So the rate of change here on the highlighted portion, it says, is the rate of change itself positive or negative? I would think of this as a negative slope, so it is negative. The rate of change here is what's important. And here, my rate of change is decreasing. I've got a decreasing rate of change because I am concave down once again. So that is the important one on this one. If I was concave up, say from this gold part here, so from 3 pi over 2 to 2 pi, that is decreasing at an increasing rate. Like I have an increasing rate of change there because I'm concave up like a cup. 9. It wants me to find the A, B, and D constants. Remember, I do it in the dab order. Dab on this problem. So now, first thing is I gotta find my midline. D is my midline. B is related to the period, and then A is my amplitude. And then the C that will be included later is the phase shift. So here, my midline is halfway between my max and min. So 1 plus negative 3 over 2 is negative 2 over 2, which is negative 1. So my midline is here at negative 1, which makes sense if you look at it. Boom, boom. My midline's there. And then if I have my midline drawn, I can now find my amplitude. Okay, my amplitude is 2. And then remember, if I have it set up as B, it's going to be 2 pi over my period. And if I have my B, my period is just 2 pi over B. And here my period to start and stop here, boom, 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 my period is 2 pi. So my B value is 2 pi over 2 pi. In this case, the top and bottom are the same. That won't always be the case. So that divides out to 1. So the trigonometric function k has a maximum at 0.020. I'll put a red dot there. It has a maximum there. So because and the reason why I know this is cosine, remember, is cosine, if there's no horizontal shift, or any phase shift, there's no phase shift left or right, there's always going to be cosine starts on the y-axis as a number. Usually it starts at 1 down here, but in this case it starts at 20. So that's how I know it's cosine. But moving on from there, my next point, my next minimum occurs at 4 pi, comma 10. So we'll say 4 pi is out here, comma 10. Similar to another problem that we did earlier. This is half my period, like from 0 to 4 pi is half my period. So my period is 8 pi. So in this case, I need to, remember this is my D value, this is my A value, and this is my, wait, I have that completely backwards. A value and what am I doing? Sorry, I'm doing this during work and I go way ahead of myself. So remember, you find it in the DAB order, and when you actually put it into the equation, though, it goes in alphabetical order. That's sorry, it's early in the morning still. So A, B, D, A, B, D. So here, let's find our D, that's our midline. Our midline in this case is halfway between 20 and 10, which is 15. Our amplitude is from 15, this is 15, from 15 to 20, which is 5. And then our B value is 2 pi over my period, which is 8 pi, which simplifies to 1/4. So my amplitude should be 5, so I should have 5 at the front. That eliminates C and D. My D value should be 15 at the end, cool. And then 1/4 should be my B value. Here on problems like these, they give you a couple of functions, and one thing to know is you need to know the sine and cosine graphs on these. So remember the sine graph, if this is 0 pi over 2 pi 3 pi over 2, and this is 2 pi, these alternate between 1 and -1. And if this is sine, I start at the 0, go up to 1 first. Go up to 1 first, cross here, ends up here, okay? So remember sine, its first max happens here, and you'll notice that it goes up first, normally, unless it's negated. And then for cosine, it would just, there's a little bit of a difference. So cosine of x -1. This is pi over 2, pi 3 pi over 2, and 2 pi. Remember, cosine starts up here at 1 and goes down. So cosine, its first max is here at 0,1, whereas the first max of sine happens at pi over 2, 1. So that's a difference, and notice that it goes down first. So let's use, like, that was just a little bit of a lesson that we'll use in this. So let's use our points here to label my axes. F is at 0, 20. G is at pi and 16. 2 pi, 12. 3 pi, 16, and 4 pi. So if I have my function, this is where my phase shift is introduced for the first time here. It wants me to write it. It wants me to just find the constant values. I don't have to write the equation. I just need to find the constant values of A, B, C, and D. Let's do that. So remember, I'm going to do it in DAB C order. I'm going to do dab first, and then I'm going to do C after that. So here, D is my midline, which is at 16. Amplitude is the distance here from my midline to the max or min, which is 4. And my B is 2 pi over period, as always. 2 pi over period. And my period here is from max to max, which is 4 pi. So 2 pi over 4 pi, which simplifies to 1/2. And now, remember on these, because my parent function is sine to find C, I've got to use all of my horizontal part labeled here in yellow. And my t values are down here, and h of t is my function output on the left. So for my c values, I've got to use that. This is kind of like a roadmap. Know my destination. I want to end up at 20 and 0. Like my first max happens here at 0. Okay, my first max happens here at 0. And for sine, the parent function, the first max happens here at pi over 2. So the first max just helps me think of different points and helps me do this a little bit. I'll show you what I mean. So let's write out b t plus c equals my pi over 2, because that's the horizontal, the y coordinate of my first max, and the parent function is sine. Once again, I'm using sine because it says to use sine. So my b value is what I just found, 1/2. My t value in this case is 0 plus c pi over 2. 0 plus c, I'm just going to simplify that really quick. You don't have to normally. I just like to get rid of that. And then I can divide by 1/2. And let's do this out here. Keep change flip. Pi over 2 times 2 over 1. That'll give me pi over 1, which is just pi. So c is pi. So here I found all my values. C is pi. B is 1/2. Boom.